Okay, the last section that we want to look at today deals with Lewis acids and bases. And the first thing you need to know is the definition of a Lewis acid and a Lewis base. A Lewis acid is an electron acceptor, and a Lewis base is an electron donor. There you go, electron acceptor, Lewis acid, electron donor, Lewis base. Acids under the Bronsted-Lowry definition are also acids under the Lewis definition. And the same thing applies to bases. If something is a Bronsted-Lowry base, it's also a Lewis base. Check this reaction out. Here we have hydrochloric acid reacting with water to produce hydronium and chloride. And we know, of course, that this is our Bronsted-Lowry. This is our base. HCl is our acid. This is our conjugate acid. And this is our conjugate base. Well, let's take a look at it from the point of view of Lewis. And you can see that the acid is accepting a pair of electrons from the oxygen on the water. And so this is an electron acceptor. Therefore, it is a Lewis acid. And I think it's even more clear that the water is donating the pair of electrons. This is our electron donor. And therefore, therefore it is a Lewis base. And we can draw the same curved arrows that we drew for Lewis acid base. Of course, in this case, because the acid and base are still Bronsted acids and bases. However, some acid-base reactions can't be classified using Bronsted-Lowry, and that's why we have the Lewis acid-base definition. Explain how this reaction fits the Lewis definition, but not the Bronsted-Lowry definition. Let's take a look at Lewis first, and you can see that the water molecule is donating a pair of electrons, so it must be the Lewis base, and BF3 is accepting the pair of electrons, and thus this would be our Lewis acid, and this would be our Lewis base. But let's take a look at those words, acid and base, carefully. Is the acid donating a proton? No, this is not donating a proton. So we'll write here, not a proton donor. Therefore, it's not a Bronsted acid. And is the water, the base, is that, or the Lewis base, is that accepting a proton? No, not a proton acceptor. And so we can't use Bronsted-Lowry definitions for the acid and the base here. We have to use Lewis acid, an electron acceptor, and Lewis base, an electron donor. Well, let's try a practice problem and then we'll call it a day. It says, in each case below, identify the Lewis acid and Lewis base, and I'm going to add something to it. We'll put here, and draw curved arrows. I mean, you only need one curved arrow per reaction here. But let's take a look. You can see that we're forming a bond in the first one between the aluminum and the oxygen. And where is that pair of electrons coming from? Well, it's coming from the oxygen on this carbonyl. Therefore, we're going to draw an arrow from the pair of electrons, and it's going to end up on the nucleus of the aluminum atom. And since the oxygen is donating the pair of electrons, this must be my Lewis. This is my Lewis base. And the aluminum trichloride must be my Lewis acid. Well, let's take a look at the last one. We have a bond being formed between this oxygen and hydrogen. And so we'll draw in the lone pairs on the oxygen of the carbonyl. And we're going to have to take one of the protons off of the hydronium. So we're going to draw our curved arrow starting on the Lewis base, because it is an electron donor, over to the acid, which is an electron acceptor. So this is our Lewis base, and this is our Lewis acid, just like that. And there you go. We identified a Lewis acid and a Lewis base in each case. Again, a Lewis acid is an electron acceptor, And a Lewis base is an electron donor.